All right, today your assignment is got a couple gotchas on it, and I want to talk you through them. Um, First of all, do you get that inverse sine is only allowed in certain places? Where is it only allowed again? From there to there, right? But then a lot of people think, so 2 pi's in there, right? No, it's not. Think about this. 2 pi, I know 2 pi's right there. And you're like, what do you mean? It's right in the middle of it. No, but 2 pi is a really big number. It's like going around a long ways. It's even past 270 degrees. And this thing's only allowed, if you think of it this way, would you agree that that's 90? And would you agree that this is negative 90? So this is only allowed between 90 and negative 90. And where's 360? It's not in that zone. You know what I'm saying? So that's one of those gotcha kind of moments that you have to watch out for. So if they ask you, what's the inverse cosine of 2 pi, you could change that in your head to 360. And you notice that that's not between 90 and negative 90, is it? Again, I know you might be thinking, but it's right here. But no, you can't think of it that way. All right? It would be there, but it goes past the zone and comes back to that. And it's outside the zone. You can't do it. Undefined is what you say. And you're done. Cool part. Those are easy to prove, I guess you'd say. All right. So let's do one that actually works, though. This is the part where I'm going to hand out the worksheet. We'll do some with you. So I'm going to pause for a moment, and then I'll record us doing a couple of the worksheets. Okay, I got the worksheet out to them, but there's one thing from yesterday that I goofed up. I just plain messed up, and I got to explain this to you. I'll explain how you should do it, not how I screwed it up, okay? When I was doing cosine of x, I was saying, okay, its domain is not limited, and that's true. Cosine goes forever, right? I mean, it keeps going. So it is from negative infinity to positive infinity. But if you wanted to have a inverse, then remember how we have to limit it, and it can only go part of it. In fact, it only does that part. Only that part of cosine is the part that can have a inverse. So then let's just label the graph of cosine for a second here. Do you get that that's pi over 2? Do you get that that's pi? Get it so far? Okay, and then do you get that this is going from 1 to negative 1? You get that? Then those right there are what you should use for the domain and range of inverse cosine. So if I'm going to change this to inverse cosine, its domain is the same as the range from this picture, which would be from negative 1 to 1. I did that part right, and it actually touches those. And then the range is the domain of the old one. And again, I said last time that it was from negative infinity to positive infinity. I was wrong, because only this part right here, from here to here, can have a inverse. So therefore, the range is now 0 to pi. And it can touch 0, and it can touch pi. All right, so it's that part right there that I just wrote in blue that I messed up yesterday. And I was thinking that domain had an unlimited. It keeps going forever, and it does. But we're artificially limiting it to only going between here and here so that it can have an inverse. And therefore, when I reverse and every domain becomes a range, the domain of the old one was from 0 to pi, and that becomes the range of this one. All right. So, enough talking about that, though. Let's go back to the new stuff that you're just about to do right now. Let's skip past number 1 because a lot of you have already done that. You want to pick one out for me to show you? Okay, read me number 4. Like that? Okay, good. My first thought is I'm going to rewrite. I really like writing it like this. Cosine of theta is equal to negative root 2 over 2. It helps me see that they want an angle. All right, next thing, I'm going to make myself a little picture. And where is inverse cosine allowed? It's only allowed here to here, so therefore it can't be here and it can't be there, right? All right, I'm going to get that little arc out of there. So can't be here, can't be here. Next thing, where is cosine negative? Only over here. And it can't be there because that's where cosine would be positive. So now I'm down to this triangle right here. Now I know where to put my sides. And the opposite over adjacent, cosine is adjacent over hypotenuse. Adjacent side will be negative root 2, and the hypotenuse will be 2. And a lot of people struggle with that one right there. Can anybody just tell it? Root 2. Root 2. If it was a 1, then this would have to be a root 3 right here. It was going to be 1, but it's not. So it's a root 2. So that's a root 2, 2 triangle, which is exact same proportions as the 45, 45, 90. It's the 1, 1, root 2. It's the same as that. I'll prove it to you. Watch. Root 2, and 2. I can go like this. 1 is to root 2. 1 is to root 2. As 1 is to root 2. 1 is to root 2. See? It's the exact same thing. Or, if you don't like that way, I can go 1 is to root 2 as root 2 is to 2. And watch what happens when I cross multiply. That gives me 2. That gives me the square root of 4, which is 2. So it's true. So that's a 45, 45, 90. So the answer is 45. No, it's not. Why isn't the answer 45? Because 45 is, if you said, where's 45? I'd say it's right there. And you're not there. You're over here. So if that's not 45, what is it? Yeah, instead of a pi over 4, you'd say 3 pi over 4. So the final answer for this one is 3 pi over 4. There's a few gotchas on this, and that would have been one of them. I bet a lot of people would have said pi over 4. Okay. Yes, sir. Yes, you may. One more. Tell me which one. Numero dos. Read it. Inverse cosine. Wait a minute. Of negative 1? You mean like this? Okay, because there's no equals in there, is there? Because that makes a difference. Okay, good. Then I'm going to put it over 1. Then I'm going to rewrite it. Do you agree with all that so far? Now, do you get that I can't do a normal triangle because cosine's adjacent over hypotenuse and they're the same size? As soon as you notice that wait a minute, I can't have the adjacent and the hypotenuse be the same size, then you know you're at one of these 4 spots. And I would just quickly draw them and say, okay, that's 1, 0, that's 0, 1, that's negative 1, 0, that's 0, negative 1. And then I would say, where am I? Cosine y over r. No, was that x over r? That's x over r, isn't it? Sorry. Cosine's x over r. Some people are talking in the back, and I'm trying to decide if I should talk to them about that or not. Okay. Thank you. All right. So x is negative 1 and r is 1. Where can I make this work? Where x is negative 1? That looks like that. The radius is always 1, so I don't have to worry about that part. So it's really down to x has to be negative 1. That's the only place where x is negative 1. That's a reminder to do my attendance. Second one. Stop that reminder. Okay. Okay, so I must be here. Now, is inverse cosine allowed right there? Kind of a judgment call. It's like right on the edge of the zone, right? So when I say it's allowed from here to here, does that include the ends or not? It does. So yes, it is allowed there. And yes, your final answer is, well, what do we want here? We want an angle, right? What angle is it? Pi. Pi's down. Answer down. Okay, I want to give you a bunch of time to work with a bud, so find one and sit next to them.